the solution to that one problem with fractions, the very last one. And I think 3 of the 4 groups came up with the correct answer, 30/11. With all these fractions, you want to find a number that will cancel all of them evenly. In other words, you want to find the smallest number that is a multiple of all 3s. We call that the LCD, or the least common denominator. Sometimes it's LCM, least common multiple. Depends on the context. But 12 will cancel 3, leaving 4, 12 will cancel 2, leaving 6, and 12 will cancel 4, leaving 3. The beauty of this is that after you cancel out those fractions, you're left with all kind of integer values, and you don't have to work with fractions anymore until the very end. So 12 cancels the 3, leaving the 4. So I just took the 5x times 4 and brought it down here. 12 cancels the 2, leaving 6. But this 4 plus x is a sum in a numerator, so we need to put it in parentheses and multiply that 6 by each one of those pieces. 12 cancels the 4, leaving a 3. And then there's that x minus 2 binomial factor there. Over here, nothing cancels, so we just multiply 12 times 1 and get the 12. So from here to here, I just canceled out the denominators. And from here, it's to use the distributive property. Distribute the 3 through, distribute the 6 through. There's a negative in front, so both of these pieces will be negative. Get all the like terms on one term, collect them, simplify them, and then you start using the properties of equations. Get rid of the 3x, bring all the x terms over to the left. Add 24, take all the number terms over to the right. And then eventually you'll get to a simple linear equation where all you have to do is divide by 11 to get 30/11 for today. And that's on graphs and lines. So if you've taken a, say, algebra course here recently, or not even recently, probably in about the 2 previous algebra courses you took, whether it be in high school or some other place, involved looking at the equations of lines. And we're going to do other things with lines, like solve systems of equations, and we're going to be doing linear regression where you have a scatter plot and you need to find the equation of a line. And so it doesn't hurt to review some of the things you've seen before, because every time you see this topic again, you learn more about it and you see more connections. So I'm not going to say too much about it, but I did provide you this list of notes here in the e-learning site. And you will find that if you go to the textbook, some of this stuff is exactly there. So this is your author's stuff. We're looking at the equation of the line, and it can come in multiple formats. It can come in this format, ax plus by. This is called the standard form. And sometimes when we write the equation of the line, we're used to writing y equals mx plus b, and that's fine if you want to write that. But sometimes my math lab will say, write your answer in standard form. So it's specifically asking for a particular form. There is stuff in here about writing vertical lines and horizontal lines, and I'll come back to this. But what I'd like to do is to go through some of the problems from the section, and I'll refer you back into the notes where you can see the formulas that are used in each case. And maybe since there's lots of different sections, maybe we'll just try to go through one of them. Okay, so the first one says sketch a graph of the equation in a rectangular coordinate system. And so I'll just take a look at number 8 here. This is something that maybe you did even in the previous section. There's a lot of things that we can do to this line to manipulate it, but probably the easiest way to graph this is to graph with intercepts, the X-intercept and the Y-intercept. The X-intercept is a point on the X-axis, and the Y-intercept is a point on the Y-axis. And any point on the Y-axis has an X-coordinate of 0. So as soon as you let X be 0, you're looking for the Y-intercept. And as you know, these ordered pairs that we're going to graph, they go together. The X and the Y go together. You can't choose one X and then choose some arbitrary Y. You have to calculate the Y because the point has to fit together. Every point on the X-axis has a Y coordinate that is 0. So if we're looking for the X-intercept, we choose Y to be 0. So first this one. If X is equal to 0, and I rewrite the equation, replacing 0 for x. It's always nice, easy, I say. Probably the easiest number to plug into an equation is 0 because everything that's attached to the 0 just goes away. 0 times 8 is 0. So we end up with negative 3y equals 24. And then solving that equation, y equals negative 8. So when x is 0, y is negative 8. And that gives you 1 point on your line. It's called the y-intercept. For the x-intercept, the calculation, you're going to let the y be 0. So you start off with your original equation and replace the y this time with 0. And 3 times 0 is 0, so that whole term just goes away. And you get 8x equals 24, and it turns out that it's 3 because 8 times 3 is 24. So when y is 0, at the same time x is 3, and that gives the other point. Now you can go all day like this and just start choosing new x's and calculating the y, or choose new y's and calculating the x, and you'd generate a lot of points. But we really only need 2 points to graph a line. So here's what the graph looks like. 0, negative 8, I'm just going to put it right here, say that that's negative 8, and then 3, 0, just going to put a 3 there, 3, 0, and then connect them together. And that's how you graph a line. Now, in my math lab, when they ask you to graph like this, they're going to put a line on at least this is how they've done it in the past, and you can confirm this. They're going to put a line like this on the horizontal axis. And then it wants you to take that point right there and drag it down here to negative 8. So you move this one down here to negative 8 so that that point becomes this point. Then the line will be like this. Then you got to take this point and drag it to 3. And so finally you'll end up with the intercepts graphed, and so therefore you have the graph line, and then you can check the answer at that point. So my math app actually allows you to graph lines. All right, so this was find the slope and the y-intercept of a graph. And so the easiest way to see that is I'm going to go to the top of this page, and here is the standard slope-intercept form of an equation. And if you have the equation solved for y like this, then the number that's in front of the x is called the slope, and the number that stands alone is called the y-intercept. So in this problem, if you can get the equation to look like this form, then all you have to do is to look at the equation and pick out the slope and the y-intercept. Y equals 3x plus 2. All of these equations are solved for x. So the number in front of the x is equal to the 3. And that's the slope. So the slope is 3, and then the y-intercept is the number that stands alone. And so the y-intercept is 2. Number 13, what is the slope? So first write down the slope, and then write down the y-intercept. And here's your hint. X over 4 is the same thing as 1/4 times x. Okay, it looks like you have a pretty good handle on that. A couple answers I saw, usually we won't include the x as part of the slope. The slope is a number. It's the number in front of the x, so we don't actually include the x. Slope is 1/4, and the y-intercept is 2/3. All right, so this one says give the slope and the x-intercept. So why don't we do problem, well, how about number 20? Usually for these problems, you have to, devise some kind of strategy. How are you going to find that number? If you know how to find it, then it's just a matter of going through the steps. So the slope, one way that you can find the slope is to find 2 points on the line and then calculate the slope between those 2 points. Another way to find the slope is to convert this equation like you did in the group work, solve it for y. If you can solve this equation for y, then the number in front of the x is the slope. So that's one strategy. So how to find the slope? Solve for y. All right, I'm going to start with the original equation. Subtract 9x from both sides. So that those 9x's go away. We can't combine the terms negative 9x and 4 together. We just write them next to one another. We say that they're not like terms. So we can't combine that to get negative 5x, for example. And then finally, we're going to divide by 2 to get the y by itself. Y equals negative 9/2. See how I rewrote this? Some of you are writing negative 9x over 2, which is also correct. It's just that when we want to find the slope, we want to bring the number out front because the number out front is the slope. And then plus 4 over 2, which is 2. Now, we know the slope is negative 9/2 because it's the number in front of the x. We know that this number over here is the y-intercept. It's the value b in our equation, which is 2. The problem, however, asks for the x-intercept. And so for the x-intercept, we have to use some other method. And I think probably the easiest method is what we did here. When you're looking for the x-intercept, choose y to be 0, and then solve for x. So that's going to be the strategy, and now it's just a matter of carrying it out. So I'm going to put y in there for 0, and then calculate the x that goes with it. Two times 0 is 0. So we get 9x equals 4. And then if you divide both sides by 9 to cancel out that 9, you get 4/9. So here is the x-intercept. 4/9. There are lots of other ways that you can do this, but I'm just going to show one. And at some point, if we have 2 points, we'll find the slope of the line using the slope formula. All right, this next grouping says to write the equation of the line with the indicated slope and y-intercept. They give you the slope and the y-intercept, and those translate directly as our m and our b inside the slope-intercept form of the equation. So this one, there's really no work. All you have to do is to write the equation, y equals mx plus b, and then replace. So let me do this one here, number 24. We start with the slope-intercept form of the equation, like that. And then they tell us that the slope is 6/7. And remember, the slope is the number in front of the x. So we're going to replace that m with 6/7. And the b in that equation is the y-intercept. We're going to replace that. In math, the technical term is substitute. We'll substitute in. And so you're done as soon as you put those numbers, 6/7 for m, and then minus 9/2 will go in. We usually write minus 9/2 instead of plus negative 9/2. Those are the same. And here it is. There's your equation. So not much to do on that one. Now, sometimes they might ask you to put in standard form. So I'll just do that one here. Convert to standard form. Now, they might not ask you to put it in standard form every problem, but some of them they will. And the standard form is this one right here. What's key about this form, ax plus by equals c, is that usually the first number there, a, is a positive integer, positive whole number, and b can be positive or negative, and then c is a number as well. So some number times x plus some number times y equals c. That's the standard form. So what I'm going to do is I can't have fractions in the standard form, and so I want to get rid of all the fractions. So I'm going to multiply this entire equation by 14, because 14 is the LCD between 7 and 2. So I have to take that 14 and multiply it by every term inside the equation. I got to multiply the 14 times the y, bring down the equal sign, multiply the 14 by 6/7 x, bring down the subtraction sign, and then multiply the 14 times 9/2. And just what the same thing that occurred in our other example, when we choose the LCD, the 14 will cancel the 7, leaving 2, so we have 2 times 6x. Over on this side, there's nothing to cancel, it's just 14y. And then 14 cancels with the 2, leaving a 7. So minus 7 times 9. Doing a little simplification, you get this. It's not quite there yet. We have to have on the left-hand side something x plus something y equals something. So I'm going to bring the 12x from the right-hand side over to the left-hand side. And then the new equation would be negative 12x plus 14y equals negative 63. And there's one more step. Because we want that first coefficient, the number in front of the x, to be a positive number, we're going to multiply the entire equation by -1. And if you multiply by -1, that basically changes the sign of every term in the equation. So negative 12x becomes positive 12x, positive 14y becomes negative 14y, and we'll write that as minus 14y. And then negative 63 becomes positive 63. Okay, so here's the kind of the standard equation. Something x plus something y equals something else. And just have a huge variety of problems that you can do with these lines and trying to understand the equation of the line. Okay, let's take a look at one of these graphs here. You know, maybe we'll look at number 26. And you know, the problems just keep coming back on just about all of these. If you can calculate the slope, or you can identify the slope, if you can calculate the x-intercept and you calculate the y-intercept, for these problems, you can go from any representation, the graphical representation, the equation, or a couple of points, and convert to any of the other ones, the other representations. But in problem number 6, they give us the graph. First thing you want to note is that the scale goes from -5 to 5, so each one of these little markings represent a 1. Same thing on the vertical scale. Where the line crosses the y-axis, right there, that point is the point 0,3 on the graph. And for most of the lines that we will encounter, the number where the line crosses on the y-axis, that's called the y-intercept. Now every point on the line, on that vertical axis, the y-axis, has an x-coordinate of 0. So when you see the point 0,3, the b value that you put into the equation, if you were going to write the equation, is just the y coordinate there. Because every point on the y-axis has a x coordinate of 0, that's not very interesting. So this is the y value we're after. Similarly, where the line crosses the x-axis, is the x-axis, y-axis up here, that point right there is the point 1, 0. Where the line crosses the x-axis, that's known as the x-intercept. And sometimes instead of writing the x-intercept as a point, like 1, 0, we just use the x-coordinate. And we say the x-intercept is 1. They ask you to find the x-intercept, the y-intercept, and the slope, and then write the slope-intercept form of the equation of the line. So the last thing we need is the slope. Now I'll show you 2 ways to find the slope. And one of the things that you'll notice is this line, as you read it from left to right, decreases, goes from higher values down to lower values. And if a line decreases, it's going to have a negative slope. If a line increases, it's going to have a positive slope. All right, now for this one, I'm going to go grab earlier on. You see this definition of a slope of a line. It's in your sheets. Are you familiar with this? Okay, Joe asks, sorry, Joe, I missed your question. It says, so the standard form can't ever be negative. You know, some books allows it to be, and so some books will just say, some number times x plus or minus some number times y equals number. I'm not sure if this textbook says that a value has to be positive or not. So if it is negative, just multiply the whole equation by -1. Certainly it can be, but it just depends on whether they want your final answer in a form where that first coefficient is a negative number. All right, so this is what we're going to use for this problem. And the reason we're going to use it is because we have 2 points. We have the point 0, 3, that's this one here, the y-intercept, and we have the point 1, 0. So with those 2 points, I'm going to use this equation. This, they call it the definition of the slope. So it doesn't matter which point you call the first point, which point you call the second point. The key is that you're going to subtract the y coordinates on the top, and you're going to subtract the x coordinates on the bottom. And you have to go in order. So x1, y1, x2, y2. We're going to take those points and break them up into individual x and y values, and then plug them into here. So if I take y2, which is my 0, and subtract y1, which is 3, get that. And then if I take x2, which is 1, and subtract x1, which is 0, here are the numbers that go into that formula. So 0 minus 3 is -3, and 1 minus 0 is 1. And we can simplify -3 over 1 to be -3. So there's the slope. The final thing that they ask you to do in this problem is to write the equation, y equals mx plus b. They want it in that slope-intercept form. Well, we just calculated the slope to be -3. Earlier in the problem, we calculated the y-intercept to be 3. Yeah. So the y-intercept is 3. So we have y equals -3x plus 3. If you wanted to check your answer on this, just choose your 2 points. Notice that when you put in the point 0, 3 into this equation, or if you put the point 1, 0 into that equation, both of those points will work in the equation, make a true equation. So for example, if y is 3 and x is 0, then we have an equation that looks like this. That's 0, so we get 3 equals 3, and that's a true statement. Checks out, as we say. In this one here, choose the other point, put in 0 for y at the same time that you put in 1 for x, and this is what the equation would look like. If you work that out, you'll see that 0 equals 0, and it works as well. So any point that you have that goes into the line that you calculate, you should be able to check it like this. All right, there's one other thing that I want to do with that problem. I'm going to blow up the graph here. Another way, and it particularly works when in the graphing setting like this, if you look at rise over run, you can calculate the slope from the graph. So the rise is the vertical distance that you would travel to go from one point to the next, and the run is the horizontal distance that you would go from one point to the next. So let me draw those on here. If we go from this point here down to this point here, we have to go down 3, think of that as -3, and that's going to put us right here. And then from here, we go right 1. And going right is in the positive direction. So the rise is -3 and the run is 1. Rise is -3, run is 1. So from the graph, down 3 over 1, down 3 over 1, and you see that you get the same slope. Without using this formula up here, without using this formula, just looking at the graph, down 1, down 3 over 1, rise over run. So I'm trying to just show you lots of connections between the graphical and equation formats, different representations of an equation. All right, for this next group, they're asking you to graph each equation or pair of equations. And so we haven't done a horizontal and vertical line yet. So maybe I'll take a look at number 34 here. X equals -3 and Y equals 2. Anytime you have an equation that has, say, X equals -3, then if you think of all the points that would work there, the way that we do it, there's no Y in there, so you can think of it as, you know, just 0Y. There's not even a Y equation there. And whatever Y coordinate we have, we're going to multiply it by 0, so it's not there anyway. So, but we do know that for whatever Y we choose, -3, -2, -1, 0, 1, 2, or any number that we choose for Y, we're going to multiply by 0. X will always be equal to -3. Now, many students just memorize this, that the equation of a vertical line is X equals some number. That's fine too, but this is kind of the background behind it. And so if you graph all 7 of those points, there's -3. You have -3, 3, -3, 2, -3, 1, -3, 0, -3, 1, -3, 2, -3, 3. What you generate in this from this table are all these points that fall on the same vertical line. So any line that is vertical will have an equation, X equals the X coordinate of a point on the line. And similarly, if you were to generate a table for the equation Y equals 2, well, there's no X in there, so it must have been 0X. And again, X can be anything because you're going to multiply it by 0, and it's just going to go away. And every time, for whatever X you put in there, the Y is always going to equal 2. So you generate all of these points where every single Y is 2. So here's Y equals 2. You have -3, 2, -2, 2, -1, 2, 0, 2, 1, 2, 2, 2, and 3, 2. You generate all of these points on a horizontal line. So in summary, any vertical line has the equation X equals some number. And that number is an X coordinate of any point on that line, because the X coordinate on any vertical line always has to be the same. In our example, the X coordinate was always -3. And for a horizontal line, it's always going to have the equation Y equals some number. Well, what number? Well, it turns out to be the Y coordinate of any one of those points, because the Y coordinate is always 2. So you'll have some horizontal and vertical lines as well that you'll need to find the equation for or graph. All right, number 47 through 50, those are similar because they ask you to find an equation of a horizontal and vertical line. So let's take a look at number 48. And what I'm going to do with number 48 is I'm going to graph that point 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. So what they've given us is this point, and what they want us to find are the equations, 2 different equations, one for the horizontal line going through that point. It's that one right there. And they also want the equation of the vertical line going through that point, and that's right there. The vertical line is always of the form X equals some number. Well, if you focus in on this point right here, what is the value of X? There it is, -5. So X equals -5 is the equation of the vertical line. For the horizontal line, it's always an equation of the form Y equals some number. And the only number that we can use here, every single point on this line, every single point has a y-coordinate that is equal to 6. So the equation of the horizontal line is y equals 6. So a couple of examples there dealing with horizontal and vertical lines. There's just a huge variety of points, of formulas and ways that you can determine slope, y-intercept, x-intercept. There will be some situations where you are given a point and a slope. And it turns out there's another equation of the line. This is called the point-slope form, where what you do is you take the point and you break it apart into its x and y coordinates, call the x-coordinate x1, call the y-coordinate y1, and then you also have the slope. And if you put it in this format right here, it's a quick way to find the equation of the line. It's just one of those many different ways that you can represent a line, including the slope-intercept form and the standard form. The special ones are the horizontal and vertical. Okay, so using this, and going back to our example, we're going to start y minus y1 and write this generic equation. Why do we use this form? Because they give us the slope and a point. And I'm going to do number 54. The x-coordinate and where you put it, now there's two x's in here. There's the x and there's the x1. The x1 is the number from the point. This x stays in the equation, doesn't change. This y doesn't change. But it's this x1 and this y1 that we get from this point. And that's one of the confusing parts here. We're going to put 2 in for x1, because that's the x-coordinate of the point. And we're going to put y1 equals -5, so that the x1, y1 goes together. So in place of the y1, we're going to put -5, but you have to be very careful about negative signs. The y1 is a negative number, so it looks a little strange. This subtraction sign always is part of the formula, so it has to come down. So we're subtracting a negative. Now, we know how to handle that. It's just, don't just ignore that negative sign. It is part of the formula. And then we have the slope, which is -10 from the problem. And we have the x1 is equal to +2. So we're going to put all those values in there. Notice I did not change the x and the y. I only changed the x1 and the y1. So once you have those numbers in, then you just kind of work it down and simplify using properties of algebra. Make sure you distribute that -10, and you have a negative times a negative. And then we're going to subtract 5 to finally get our equation in slope-intercept form. So a recap is if you have a line that goes through this point to -5 and it has a slope of -10, then write this equation in slope-intercept form. We start with the other form and then we work it down so that it's of the form y equals mx plus b. You can see that the number in front of the x is -10, and that corresponds with the slope of -10. You can also calculate that if you put 2 in for x and -5 in for y, you can check that that point actually works in this equation. -5 here, 2 times -10 is -20, and -20 plus 15 is -5, and that point would work. So the point works in our equation, the slope is correct, and so now you can see these problems are going to get a little messier because sometimes you have slopes that are fractions, sometimes you have slopes and points that are decimals, but the arithmetic is still the same, it's just not as easy. All right, let's end on one last problem, and that's this one here. These problems here are very similar to the one up here, but there's one additional step that we have to do. And that is, up on this one, they gave us the value of the slope. Down here, they don't. So there's one additional calculation that we must do, and that's to calculate the slope. So let me just try number 62 here. It doesn't ask you to do this, but if you wanted to, you could sketch a line of the 2 points, 2, 3. and -3, 7. So there's the 1 point, and there's the other, and here's the line containing them. So they want you to find the equation of that line. Now, a couple of things that you can see from that line is that it's decreasing as it goes from left to right. So therefore, you know the slope is negative. You also know that the y-intercept is about right here, and that number is a little bit higher than 3, but it's lower than 7. So it's somewhere between 3 and 7. You know, maybe it's 5, or maybe it's 4, or something like that. All right, now let's go through the calculations. I'm going to use this formula first, and then I will stop after we calculate the slope, because we're getting close to our time here. So I'm going to take the y-coordinate, subtract the y-coordinate, 7 minus 3, and then I'm going to take the x-coordinate and subtract the other x-coordinate. And so this is 4 over -5, or -4/5. So we're going to be working in fractions here. All right, so the final step then would be to take this point slope form like we did before and plug in. You can choose either the point 23, or you can choose the point -3.7. I will always choose the point that does not use any negatives. So I'm going to take the y-coordinate of that point, take my slope, -4/5, x minus the x-coordinate, and then simplify it from there.